Coulomb's law is a milestone in the study of electrostatics. It gives us a quantitative statement about the force between 2-point charges at rest. So if we have given with two charges and the charges are at rest, let the first object is with charge Q1 and the second object with charge Q2, and these bodies are considered as point charges. Why? Because the distance between these two bodies is way too bigger than the size of the bodies itself. So that's why these bodies are called point charges, because they are considered as points. It was given by Charles Augustin de Coulomb. He was a French physicist, and the law simply says that the force working between these two charged objects is directly proportional to the product of the charges on both the bodies, and the force is also inversely proportional to the square of the distance between these two bodies. So let's R be the distance between these two bodies. And combining these two, we can simply say that F is proportional to the product of the charges and inversely proportional to the square of the distance between them. And thus we can write F is equal to K Q1 Q2 upon R square, where K is the proportionality constant. This is the scalar form of Coulomb's law. Here we don't discuss about the direction, though whenever we deal with force, we talk about direction because force is a vector quantity. But we start with simple calculation where we ignore the direction in the first place. That's why in your book, the definition or the formula for the force is given in scalar form. Here we don't talk about direction, and the mod Q1 multiplied by Q2 is just to say that it will only give positive value, which means no direction is specified. The resultant direction of this force is always along the line joining the two charges. Let's say there are two charges, one is Q1 and the other one is Q2. Then the line joining these 2-point charges will define the direction of the force. So the direction of the force is only along this line. So maybe towards left, what you can see on the screen, or maybe towards right. It can be anywhere. So that all depends on how we start calculating the force. So force on charge Q2 or force on charge Q1, that we will discuss. Now, we talked about the proportionality constant in finding out the Coulomb's law or the Coulomb's force, and this is the value of the proportionality constant, that is 9 into 10 to the power 9 Newton meter square per Coulomb square. And this value of K is valid when we are dealing with the charges in vacuum or in air. Let us understand the vector part of Coulomb's law. Here, charge Q1 is placed in space, and the position of this Q1 is R1. R1 is the radius vector of this charge Q1, and R2 is the radius vector of the charge Q2. So these are the positions of Q1 and Q2. and positions are denoted by vector r1 and vector r2. For convenience, this vector r21 is actually the distance between q1 and q2, okay, in a particular direction. So it is a displacement, okay, and this is equal to r2, vector r2 minus vector r1. And how can you see the direction of this displacement vector? It is from 1 to 2. So r21 is directed from 1 to 2. In the same way, r12 is directed from q2 to q1, okay, opposite of r21. r12 is opposite of r21. Further, now we talked about f is equal to k q1 q2 upon r square, where k is equal to 1 upon 4 pi epsilon naught. This is the proportionality constant, where 4 and pi you already know. Epsilon naught is the permittivity of free space, and the value of epsilon naught, that is the permittivity in free space, and for vacuum it is 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. Now, once we know all these things, and once we have established that R21 is a vector from, now once we know everything, and once we have established that R21 is a vector from q1 to q2 in the direction of q1 to q2. So it is r2 minus r1 is r21, but the direction is from charge q1 to charge q2. Further, we also need to know how to write this vector r21 as a multiple of unit vector. So to do that, r21 can simply be written as r21 inside the mod, which gives only the magnitude of this vector r21, and that can be multiplied by r21 cap. This is the unit vector which gives only the direction. So the unit vector r21 is actually r21 vector divided by the mod of r21. Now we can simply use all these information to write force on charge 2 due to 1, which is a vector, is equal to 1 upon 4 pi epsilon naught multiplication of the charges q1 q2 divided by r21 vector in a square, okay, and then we will simply use the unit vector r21. Let us understand the direction of this force in picture. So what happens here is that both the charges are of same type, like positive or negative, then product of these charges are always more than 0, that is plus, positive, okay. And when that happens, then what we are finding here, force on charge q2 due to q1, force on charge q2 due to q1. If both the charges are like charges, like both the charges are of same kind, then there will be repulsion, as we know. So q2 will be pushed further away, and so F21 is in which direction? From q1 to q2, and for that we have the direction vector or the unit vector r21 that we have already established. So that's why on the right hand side in the formula, the direction is only given by this quantity cap R21. That is the direction of the force, and that is from Q1 to Q2 towards this. Alright. Suppose if the charges are of unlike charges are there, like one is positive, one is negative, then what will happen? This quantity Q1 and Q2 will become negative. Alright. So our F21 will become 1 by 4 pi epsilon naught, and Q1 Q2 multiplication of Q1 Q2 will become negative, so it will be minus Q1 Q2, and then same thing we will write, and then vector will be also the same. But just remember, because of this negative sign here, our vector will become minus R21. That is from, not from Q1 to Q2, but from Q2 to Q1 in opposite direction. So force will be opposite of what we have seen before. So force will be from Q2 towards Q1. Okay, that's why this F21 for charges, unlike charges, Q1 Q2 is product of Q1 Q2 is less than 0, will be from Q2 to Q1. So this is the significance of this direction diagrams. So further we can write that F21, this is the case when Q1 multiplied by Q2 is less than 0, unlike charges. Okay, for that F21 is 1 by 4 pi epsilon naught Q1 Q2 R21 mod square. This is just the magnitude, and instead of writing R21, now we will write R12. Or if you want to write R21 here, then you have to put a negative sign before that, and everything will be fine. So we can play with these vector units very easily. Let us also understand there can be many charged bodies, and then if we have to find the total force on a particular charge due to all other charges, then we will individually find the forces using the Coulomb's law. Like we will find force on 1 due to 3, force on 1 due to 2. So individually we'll find out, and then finally we will add the vectors using the vector addition. So the force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges, taken one at a time. Okay, so the individual forces are unaffected due to the presence of other charges. So that's why we just have to figure out the individual forces, and then we can add it, and this principle is called principle of superposition. So the vector sum or the force on a particular charge due to any other charges is not affected by any other charges nearby, and that principle is called principle of superposition. And this is the definition or statement for principle of superposition. So I will just ask you to please write it down a couple of times to memorize it the way you want to write it in the exam. Alright, thank you. One more thing is that if you want to master this concept, you have to do problems, couple of problems. So you can just do the questions at the exercises at the end of your chapter.